Hey there, Chem Squad. Today we're going to look at aqueous solutions. What is exactly an aqueous solution? Well, aqueous solutions was first introduced to you guys in grade 11, and what it really means is creating a solution that can basically contain solutes dissolved in water. So, any kind of solution is basically a mixture of dissolved solutes in water. Because water is considered to be a universal solvent, it can naturally dissolve many different types of solutes. So we can get quite a variety of aqueous solutions. But not every single type of aqueous solution is similar to each other. Okay, we do have ways of representing aqueous solutions. So if you kind of look at this example here, if I take something like hydrochloric acid, okay, hydrochloric acid is typically a liquid, and if you were to dissolve it or add water to it, it would actually form H plus ions and Cl ions. Okay, these ions are said to be dissolved, and if they are dissolved, then the state that they're in is an aqueous state. So by combining a liquid with water, we have made an aqueous solution. So this part here generally represents the aqueous solution. But like I said, not every single type of substance that dissolves in water dissolves in the same way. Okay, so to get a understanding of that, let's just take a look at what it means to dissolve and what it means to dissociate. Dissociation is a term that we use basically meaning to separate. It's different from decomposition, okay, and we'll kind of see why. So at the bottom here, I have three diagrams. I basically have a crystalline structure of sugar. So basically just different sugar molecules stacked on top of each other to form a sugar crystal. The type of sugar that I've chosen is C6H12O6, which is basically glucose. In the middle, we have a salt crystal. Okay, so basically many NaCl molecules or compounds stuck together, okay, to form a larger crystal or solid. And then finally, we have some fats or oils. Fats and oils are actually made up of fat molecules called fatty acids. So let's see what happens when we basically dissolve these substances in water. So if you remember, water is made up of oxygen and two hydrogens. Water is considered to be a polar molecule because one end of the water molecule is more negative and the other end is more positive. Okay. Now, other polar molecules do include things like sugar. Okay, so sugar is polar. Alcohols are polar as well, but salt crystals are not polar. They're actually ionic compounds. Okay. They actually don't share their electrons very evenly with each other. Okay, so they all tend to gain or lose electrons, whereas polar substances, they share their electrons, but they don't share it evenly. Now, for fats and oils, these guys are nonpolar, meaning that they don't really have a charge, okay, on either ends of their molecules. Okay, they do tend to share their electrons completely even between all their molecules and atoms. So when we look at how sugar dissolves each of them, they all dissolve them in slightly different ways. Okay, so for example, we know that water can dissolve sugar. So when water comes in, they basically just separate the glucose molecules, okay, from the other glucose molecules that make up the entire sugar molecule. So they tend to kind of make things look more like this. So if each of these squares that I have drawn here represents an entire molecule of glucose, then what we have is that we have water molecules surrounding each and every molecule of sugar. So I'm just drawing them quickly here. There's no specific orientation to their atoms, okay? But we do have glucose molecules being surrounded by water. So if they are surrounded by water, you technically have a dissolved substance. So since water surrounds each glucose molecule, glucose is dissolved in water. So if glucose is dissolved in water, you therefore have an aqueous solution. Okay. So the key is when things are surrounded by water, they tend to dissolve in water. So every molecule of glucose that we have that makes up the crystal, they're going to be separated into individual molecules and then being surrounded by water. Okay, so if we look at what happens with salt, salt also gets separated by water. Okay, so here's another water molecule coming through. Okay, and it'll separate them at, again, many different parts of this salt crystal. So if we were to analyze what happens, okay, when they split it up, now remember, one salt molecule is NaCl. Okay. NaCl is attached together like this. And if we have that water molecule coming in and splitting it up, what ends up happening is that you get Na forming an ion and Cl forming an ion. And each one of these ions is again surrounded by water. But this time the water molecules are arranged in a very particular way. Okay. The negative ends of the water molecules are now surrounding the positive end, and the positive end of the water molecules are now surrounding the negative ion. Okay, but the same thing happens. Here, the ions are being surrounded by water, and if it's surrounded by water, salt basically dissolves in water. The main difference, though, is we actually generate ions in this process. Okay? So ions are formed when water surrounds each atom of salt. So two things happen here. Salt dissolves in water, but salt also dissociates Okay, it splits up into ions. Okay, so we also, because these ions are being surrounded by water, we do have an aqueous solution. Okay, so we have an aqueous solution, but with ions created. Okay, whereas over in the sugar, you have an aqueous solution, but there are no ions being created because the water molecules cannot separate every individual atom of carbon, hydrogen, or oxygen. But here, with any ionic compound, water will separate the metal atom from the non-metal atom, thus creating two ions. So if these two are basically aqueous solutions, okay, which dissolves, the one with the salt also dissociates. Okay, and that's the fine difference between the two, okay, between dissolving and dissociating. Dissolving simply means being surrounded by water, whereas dissociation includes the creation of ions. So let's look at the very last one. We know that water and oil do not mix, okay, and if they do not mix, they cannot dissolve. So what we kind of see here is you have water trying to separate the fatty acids, okay, but they fail. The water cannot separate the fatty acids at all. So since water cannot surround an individual fatty acid, water cannot dissolve fats or oils. Okay, they can't break it down into the fatty acids. Excuse me. They cannot break it down into the fatty acids and then surround those fatty acids to make it dissolvable. Okay, so because water cannot dissolve it, no aqueous solution is created. Okay. So hopefully this series of diagrams help with the explanation of what can dissolve and what cannot. Okay. Typically, we have a saying, like dissolves like. So polar substances and ionic compounds are similar enough for water to dissolve them. But fats and oils are not similar in polarity, okay, to ionic compounds and polar substances. So therefore, a polar substance like water cannot dissolve nonpolar substances. So the takeaway message is we can create aqueous solutions as long as water can dissolve it. Sometimes water will dissolve things and not make ions, and when they do, we just call it dissociation. All right, that's all I have for right now. I will see you guys next time. Thank you.